Okay, so we're working on this question 41. I have it big here so it comes up. And with all of these questions, you got to make sure that you really understand the context of the problem. So that's why I'm going back. So the problem you asked about is we have to go back to question 37. So let's look at it. It says a small ferry runs every half an hour from one side of a large river to the other. The number of cars X on a randomly chosen ferry trip has the probability distribution below, and they're already telling you the average, the expected value is 3.87 and the standard deviation is 1.29. So 0 cars happen 2% of the time, 1 car happens 5% of the time, 3 cars happens 8% of the time, 3 cars happen 16% of the time, 4, 27, and 5 cars happens 42. And we get a probability distribution that looks like so. All right, so it says down here, the cost for the ferry trip is $5. Make a graph of the probability distribution for a random variable m, money collected. Well, we're going to collect $0, right? We're just multiplying the number of cars times 5. This is why this is a linear problem, because we're just saying each one of these cars, right? We can make $0, we can make $5, we make $10, 15, 20, and 25. And so we end up with a distribution like this, right? And then it says, if we were, this is why this is coming out here, if we want to, what's our mean expected value? Well, if all we're doing is taking the number of cars and multiplying it by 5, the mean of that is just going to be times 5. And the same idea is going to be for the standard the standard deviation. We're just taking, if you could kind of imagine replacing these with 0, 5, 10, 15, 25, and 20 and 25, we could just put 0, 1, 2, 3, 4, 5, right? That this distribution looks exactly the same, right? But we're multiplying it by 5. So we're changing the x-axis, and that's why both the mean and the standard deviation get multiplied, because this rule right here, right? Multiplying, dividing each random variable by some number multiplies the center and multiplies the spread. But it's an absolute value, so the spread's not going to ever be, the standard deviation is never going to be negative. All right, that's why the absolute value is there. Now, if we come up to this question, it says, now the ferry company's expenses are $20, right? So how much they're paying. So we have what their costs are, and we want to find out what their profit's going to be. So we started with, right, their average, what they're bringing in is $19.35, right? So this is how much they're bringing in on average. And their spending, well, we just said that every time they run it, right, they have expenses are 20. So how much do we expect to profit? Oh man, we expect to lose, right? So this kind of tells you that they're not charging enough, right? So on average, they're going to lose 65 cents. All right, now the standard deviation, right? Does the standard deviation actually change, right? Does this 20, right, change the actual spread? Is there any way that this distribution, if we graph this for having, putting in this minus 20, right, are we changing the actual shape of this distribution? Are we right? If we change the shape of this, then the spread's going to change. But no, all we did was take this whole graph and shift it over 20 in the negative, right? We just said we don't have $5 because we have to deal with that minus 20. So the whole thing shifts. And this is why the standard deviation is still 6.45, right? We're not on a linear shift left or right. The mean is going to be changed because we're shifting that whole distribution left to right. But the standard deviation, the actual shape of the distribution, is going to stay the same. All right, so I hope that helps with this question. If not, let me know and I can explain better.